One of the challenges, so I've talked about the two kind of big things that I think students kind of struggle with in calculus, and one is kind of developing that conceptual understanding, and then the second is is understanding the notation in calculus and just kind of becoming familiar with it. There's a third challenge, and it's nothing that I as an instructor can address. The first two I focus on a lot in my class because that's what we're learning about. But that third challenge is what you bring with you into the class, and that's the algebra. That more than anything, I think when students are sitting down and they're doing their work, they get hung up on their algebra. And so my recommendation to you is when I give you these homework assignments, don't wait till the last minute to do them, and take your time, show your work, make sure that you understand what exactly is going on, and you might even, like with these problems in this homework, you might even try finding these slopes the two different ways, as x approaches a or as h approaches 0. So problem number 9, let's just go ahead and look at that. You could very easily solve this problem, set it up as h approaches 0. Similarly, you can do it as x approaches a, and that's the way I'm going to try to solve this one. So I'm going to set this up as the limit as x approaches a, difference of my y values and my x values, and I'm just going to plug in my function f of x, and I'm going to subtract f at a. Go through and distribute. Make sure you apply that minus sign to everything in the parentheses, and then just simplify out the like term, or the zeros. Combine like terms. Now what I want to do, this is where the algebra comes in. If you're kind of weak in your algebra, you don't see these things, but what I'd like to do is I'd like to get my squared terms together, and then I'd like to get my cube terms together and factor things out that way. I need to somehow get rid of that. I need to get rid of that x minus a in the denominator, because my limit is x approaching a, and as x approaches a, my denominator, my fraction becomes undefined. So somehow I need to manipulate that numerator so that I can simplify out that x minus a. So the way I'm going to go about doing that is I'm going to factor my numerator. I'm going to factor out the 4, and then I have the difference of squares. So I'm going to have x minus 2, or I'm sorry, x minus a and x plus a. Now I'm going to factor out a 2, and for these next two terms, it's the difference of cubes. So I got to remember that difference of cubes factoring technique, which is going to be a squared plus ax plus x squared. All right. Well, I'm looking at this and I see I have this a minus x, and I would really like that to be x minus a. So what I can do is I can just factor out of that factor. I can factor out a negative 1. And if I do that, then I get a minus 2 and then x minus a. So by factoring out a negative 1, I can get that factor to look exactly as I want it to look. And then if I factor out x minus a in the numerator, if I look at both of my terms, and if I factor out x minus a, I leave behind a 4, an x plus a, minus a 2, and then that trinomial. And now I can simplify out that x minus a. And I'm left with, if I multiply everything out, I'm left with this product here. So the next step now is now I can have x approach a. It's not going to be undefined any longer, and so I take my expression, and this limit as x approaches a will become 4a plus 4a minus 2a squared, And if I substituted an a here, I'm going to get a 2a squared. And if I plug in another a there, I'm going to get another 2a squared. And combining all of my like terms, I find that my slope, as x approaches a, is 8a plus 6a squared. Now I can use this for any value of a, and in this problem, in part B, I'm going to let a equal 1 for the first point, and I'll let a equal 2 for the second point, and I'm just going to find the slope. So when a is 1, I get a slope of 2, and my equation then becomes y minus 5 equals 2 times x minus 1, which is y equals 2x plus 3. That's the slope of the tangent line. For the second one, I get m is equal to 8 times, substituting 2 in for a, I get negative 8. And then using the point slope form of an equation, I get negative 8x plus 19. So that's how you could go about solving this as x approaches a. And I would recommend maybe you try it the other way as well, as h approaches 0. See if you get the same result. Good luck.